Global warming results in changing climate conditions, which causes glaciers all around the world to retreat. A glacier is a continual mass of ice and snow which flows downslope in cold regions of the earth. Glaciers are formed in regions where there is snowfall and the temperatures are low enough so that all the snow on the glacier doesn't melt. When a new layer of snow falls onto the glacier, as shown, the layer beneath it gets compressed and this cycle continues until the layers eventually turn into solid ice. The amount of snow liquefying must be less than the amount of snow that has fallen. Only then will it get converted into a glacier over a long period of time. Glacial retreat isn't often mentioned as people don't think it really affects them that much. However, it affects a lot of things.
Glaciers are important water storage facilities. They release water year-round, but during the hotter and drier months they have a significant increase in the amount of water they discharge. The Himalayan glaciers supply water to millions of people, but as the glaciers retreat, the water storage could dry up, causing many problems for the people who rely on that water each day. Hydropower also can rely on glaciers, just like some found in the Mackenzie country of New Zealand that use glacial runoff to produce power. But with less glacial runoff due to the retreat, hydropower will be impacted. Athabasca Glacier in North America and the Franz Josef Glacier in New Zealand are both important tourism glaciers. With both glaciers in a state of retreat, tourists are less likely to visit these natural attractions as they are becoming smaller and less impressive, leading to many negative effects in the surrounding areas as tourist numbers decrease.
Unfortunately, glaciers are melting. Industrial activities such as manufacturing and vehicular travel have increased drastically over the past 150 years, leading to an increase in the levels of greenhouse gases such as carbon dioxide and methane in our atmosphere. This process has caused the greenhouse effect phenomena to become more significant, which has severe implications for glaciers across the world. The new abundance of greenhouse gases in the atmosphere does not affect shortwave radiation emitted from the sun. This is because this radiation is powerful enough to pass through it, either being absorbed or re-emitted by the Earth's surface. However, long-wave radiation emitted by the Earth and other planetary objects does struggle to pass through the greenhouse gases and can become trapped in the atmosphere. As greenhouse gas levels increase in the atmosphere, less long-wave radiation can pass through, thus causing the atmospheric temperature to rise. This process can lead to increased glacial melt as warmer temperatures melt the ice.
When the glaciers begin to melt, they release large amounts of stored water. A lot of this water then ends up in the sea and contributes to sea level rise. In the last 100 years, glacier melt has played a large role in increasing the average sea level by 10 to 20 centimetres, and this is set to continue into the future. The decrease in albedo as the surfaces change will result in more shortwave radiation being absorbed, which will increase the temperature. This is an example of a positive feedback.
Unfortunately, we have already contributed enough greenhouse gases into the atmosphere that even if all emissions were stopped tomorrow, glacier retreat and sea level rise will still continue to happen. A way that we could attempt to reduce glacier retreat is by trying to cut down our emissions by travelling on buses, carpooling or cycling. This would eventually reduce the amount of greenhouse gases in the air and long-wave radiation would be able to escape, meaning the atmosphere would cool down. Another way that we could inform the country of the state of our glaciers is to make informative posters and put them in places where people will see them. We could even make Facebook advertisements to ensure we're reaching a wide audience.